Hi, good morning, class. I'll wait for 2 to 3 minutes to see if others are joining. All right, good morning. And this will be our last class for the semester for this unit. And in the last class, we looked at different types of spillways and then energy dissipation mechanisms below spillways. We also looked at the discharge equation for this flow over Augie spillway. So today we will continue the spillway design, and we will do an example of how to design a spillway profile. Now, in this, what we are going to do is look at a problem which requires us so we have to design a suitable profile or section of Augie spillway of a concrete gravity dam. And the data that we were given is that the discharge that we need to deliver to the downstream is 8,000 cubics or 8,000 meter cube per second. And the length of spillway is roughly about 55 meters. So using this information, we need to find a suitable profile. And we are also given that the downstream phase slope is 0.7 horizontal to 1 vertical. So this is the data that we are given, and we need to calculate what would be the profile. So let's say this is our upstream phase. We are assuming a vertical upstream phase. And then this would be our downstream spillway profile. And this slope is roughly about 1 vertical to 0.7 horizontal. So we need to find what this profile is going to look like. So in the last class, what we looked at is discharge over a spillway Q is given by an equation. So the discharge over a spillway is given by a coefficient K times LE times HE power 3/2. Now HE is the sum of the hydraulic head and the velocity head on the spillway. So what we saw is, let's say this is our upstream water level that is overflowing on top of the spillway. Then we have HD, which is the height from the crest of the spillway to the free surface. And then on top of it, you also have a velocity head. So you're adding both hydraulic head and the velocity head, HA and HD. Now the coefficient K, or you could say the coefficient as C, coefficient of discharge. So this is dependent on the velocity head and the hydraulic head, or in turn, it is dependent on the total head as well. And this CD usually we get based on experimental data. So let's say you do experiments in the lab by constructing a spillway, and then you measure what is the discharge that you're allowing, and then you calculate the discharge. So you get this CD. So based on experiments by researchers earlier, they developed this curve of how this coefficient C changes with HE over HD. And usually it trends up like this. So if your total head to HD ratio is increasing from, let's say, 0 up to 2, then your coefficient of discharge is also increasing. And for this purpose, in this question, let's say we take CD equals to 2.2. Then we have Q equals to CD LE HE power 3/2. Now Q is 8,000 and CD is 2.2. LE is given as 55, and then the unknown is HE. So you can calculate what would be HE. So you get HE in meters. So this is the total head, HE. So this is the head. Or the spillway crest. And HE is sum of HA plus HD. So now HA usually is a function of the depth on top of the spillway, right? So if you have spillway, then HA would be a function of this depth. And for simplicity, let's say HA is negligible. So meaning our total head is only a function of the water depth HD. So we are simplifying for the case of this example. So we calculated HE from this. Let's say it would be some H meters. So then your HD would also be H meters, because we are assuming the total head is a function of only the hydraulic head. So we are neglecting the velocity on top of the spillway. And the reason we are doing this is we need to know what is HD to get what this profile is. So earlier we discussed this profile of Augie spillway is a function of x, which is the distance along the dam, and then a function of depth y. And this profile is given by x power 1.85 equals to HD. So this is the function which gives us the profile of the Augie spillway. And to use this function, we need to know what is HD. So to get the HD, we calculate what is HE. And in this example, we assume HA is negligible. So once you get HD, then you have X, which is, let's say this is our starting point, origin 0, 0, and you're moving in this direction. So then you would have X and Y. So what would be Y from this equation? Y equals to x power 1.85 divided by 2 HD or 0.35. And you know HD is small h. So Y is 1.85 divided by 2h. So Y is a function of X. So if you have X and Y, so you are starting at a point 0, 0, and then you are moving horizontally, and then you are also moving vertically. So let's say at x equal to 0, y equals to 0, x equals to 10 meters, 20, 30, 40, 50, so and so on. So you calculate what is y until you reach the height of the spillway, which will be capital H. So what we essentially did was to use this equation for the profile of the spillway, which is dependent on the head or on the crest of the spillway. And to get the head or on top of the crest of the spillway, we calculate what is the total head, and then we are neglecting the velocity head from the total head, and simply using the function for x and y, you calculate what is y for different x. So now you get several points along the profile, and if you join all of those points, that could be your spillway profile. So this is how we can design the spillway profile for gravity dams. Now this is the design of a auger spillway. There are other types of spillways like chute spillway, siphon, or shaft spillways, but we are not going to do the design of those spillways today. So for the exam, the syllabus would be on the types of spillways and the energy dissipation mechanisms below spillway, and then how to calculate the discharge over auger spillway. So we are not going to do in-depth design of the gates of the spillway as well, but the design of a spillway profile is the important aspect that you need to keep in mind. So this is about auger spillway. Now, in the last class, I discussed about different types of spillways, but I forgot to show you one more kind of a spillway, which is a stepped spillway. So these stepped spillways are mostly used in Australia, where they want to dissipate energy as the flow is going down the spillway. So with each step, then the flow is going to drop from step to step, and with the impact, you're going to lose the energy. And also, there is going to be a lot of aeration or turbulence since the flow is going to separate from each step. So with this, you're going to see a lot of dissipation of energy in the form of turbulence. So that is another use of using step spillways. And there are a lot of experiments being done and a lot of research in this area of hydraulic engineering where new kinds of spillways are being designed. You can also do computational fluid dynamic modeling. So I'm sure you might have heard of CFD model. Have you heard of CFD model?
Yes, sir.
Yeah. So you can use CFD models as well to design this. So that brings us to the conclusion of this topic. So any questions on this? So the last lecture I have not uploaded yet. I will upload it today, and also including today's lecture, I will upload it.
Excuse me, sir.
Mhm.
Sir, can you please give a brief idea how, like, what type of questions we can expect in SEM from Unit 5?
Yeah, so it would be for a total of about 15 marks for Unit 5. And there would be a question from gravity dams, one question from earthen embankments, and one from spillway.
Sorry, you're not audible.
Sorry, I lost internet connection in between. So in terms of the questions for Unit 5, it's going to be for 15 marks in total, and you will have 3 questions. So one from gravity dams, one from earth and embankment, and one from spillways. For gravity dams, you would be asked to either check the stability or design a profile for the gravity dam section for only a few set of loadings. It could be hydrostatic pressure, earthquake pressure, or ice or wave pressure. So I would specify what pressures you need to consider. And for earth and embankment, again, you might be asked a question on the stability or factor of safety for the earth and embankment. Or if there are any theoretical derivations that we did, then you may be asked about the theoretical derivations that we did. And for spillways, it would cover whatever we have discussed in the last 2 lectures. So if you go through the notes and try to follow the example tutorial solutions that I have provided, the questions should be of the same level or should be consistent with whatever has been provided to you. So I would like to hear your thoughts or feedback on the course so far. Feel free to let me know. Please unmute yourself and you can discuss what you would like to see improved in the course. Or so how many of you are actually interested to be a hydraulic engineer in your career? Or how many of you are interested to pursue hydraulic engineering or river engineering? So any thoughts on the course so far on this unit? Do you want to see anything improved? So what is your feedback on this? So how many of you got placed? All right, so if there are no more questions or No more feedback that you want to add. So I want to ask one more last time. Do you want to say something before we leave? Is there anything else that you want to discuss?
Sir, it will be really helpful if you can just summarize what what could be asked in the exams, regarding this whole unit of particular.
Mhm. So in the exam for Unit 5, it would be for 15 marks, or up to, it could be up to 20 marks. And there would be 3 parts. The first is gravity dam, and the other is earthen embankment, and the third is spillways. So in the gravity dam, you would be asked to either design or check stability based on certain forces, either certain or specified forces. So I might specify the forces which you need to consider, or I'll ask you to consider the forces that are required. And again, earthen embankment, again, it would be similarly based on stability, and spillways, so whatever is covered in the lectures. And you need to also check if we did any theoretical derivations. So you need to go through the theoretical derivations in the lecture notes, and also try to solve tutorial questions. So this is all you need to do for the exam. And those 15 marks would be coming up from all of this. Yep. So any other questions?
No, sir. Thank you, sir.
All right. So if there are no questions, then good luck for your exams and all the best for your career as well. This would be the last class, and I think I will see you all on Wednesday for the photo shoot. That would be our first physical meeting. Yeah. I hope to see all of you there.
Yes, sir. Thank you, sir.
Thank you.
Thank you.
Thank you. Bye.
Sir, I have a doubt. Sir, I
Yes.
have a doubt.
Mm-hmm.
Sir, in tutorial 1, question number 2.
Okay, let me check.
Sir, I have a doubt. Tutorial 1, question
Mhm.
number 2.
Yes. Yeah, I'm opening up the tutorial.
Yes, sir. Sir, how will you find the uplift pressure? Sir, please solve it in the class.
So a concrete dam section is given below. Check the stability of the section and determine the value of sliding factor and shear factor. Find out the magnitude and direction of principal stresses and shear stresses at the
No, sir, not
line.
that one.
Mhm.
Different question. Different question, sir. Sir, I'll open the camera and show it.
Mm-hmm.
The tutorial we submitted. We submitted the tutorial, that question.
Do you want to show me the question? Okay, so this, I think this is best if you discuss with Dr. Beneath.
Vineet, sir, I will discuss with Vineet, sir.
Yeah, yeah,
Okay, sir. Okay, sir.
yeah.
Okay, sir. Thank you, sir.
Yeah, thank you. All right, so any other questions? So if there are no questions, then we'll close the session. All right, so I'm closing the session. Thank you and all the best for your exams.
Thank you, sir. See you.
Thank you.